In this video, I'm going to show you how to answer this Regents question involving graphing a quadratic equation. The quadratic equation that they give you is y equals x squared minus 2x minus 3. And it says to graph the equation y equals x squared minus 2x minus 3 on the accompanying set of axes. Using the graph, determine the roots of the equation x squared minus 2x minus 3 equals 0. First thing you're going to do here is actually graph this equation. To do that, go to the y equals button on your calculator, right? Your calculator starts out like this, and you go to y equals anytime you want to graph. And since this is already solved for y, all you have to write in is x squared, using this button for x, squared, minus 2x minus 3. And you look at the graph, this is what your final product should look like. Don't just try to copy it and make it look like the graph. You need to have accurate points written in. So what you need to do is go to second, graph, and you'll get your table. That's the button is yellow, and then the function above the button, which says table, is where you'll go. So when you get to this table, you can scroll up and down, and you're looking for points that will fit on the grid that's provided. This grid is 10 spaces in each direction. That means this point, negative 312, is not going to fit on your grid. So the first point I'm going to graph is negative 2, 5. Negative 1, 2, and then up 1, 2, 3, 4, 5. The next point is negative 1, 0, negative 1, and then 0, so I don't have to go up or down. And then 0, negative 3. So if the x value is 0, I'm not going to the left or the right. I'm at 0 already. And I'm going to go down 1, 2, 3 for the y value of negative 3. The next point is 1, negative 4. I go over 1 and down 4. The next point is 2, negative 3. So I'm going from the origin over 2 spaces on my x-axis, down 3 on my y. And you'll start to notice this U-shaped graph. It's come down, now it's going around, and it's symmetrical, meaning that every point on this side has a partner on the other side, the parabola. Then I'm going to go to 3, 0. 3 on the x-axis, but it's 0 on the y-axis, so I'm not going up or down. And now I've got to scroll down to see if there's any more points I can graph, and negative 4, 5. So you see a 5 up here. Sorry, not negative 4, positive 4, 5. I'm going over 4 spaces, 1, 2, 3, 4, and then up 5, and it's right across from this point over here. Next thing you're going to do is you're going to draw in your parabola, and you have to remember it's curved. So what I usually do is I draw one side of the parabola first, extending up. I messed up a little bit, so it's good to use pencil to make sure you don't mess up. You can always erase. And I try to extend the graph and put an arrow. And now I'm going to come around, extending the graph with an arrow. And this is the equation graphed. Don't forget, it says, using the graph, determine the roots of the equation. The roots of the equation are where the y value is now equal to 0. That's the only thing that's changed. So if I go back to my table, I can actually see where the y value is 0. It's 0 in these two places, at negative 1, 0, negative 1, 0, and positive 3, 0. So when you look at your graph, your roots are the place where the graph crosses the x-axis, here and here. So you just write out roots, and you're going to state the roots. The roots are the x values of these 2 points. So the roots of this equation are negative 1, negative 1, and 3. 1, 2, 3, and negative 1. Those are your roots. That's what you're going to write to get full credit.